Use the next double message. This message takes no parameters. For example, to generate a random number from a normal distribution, use next Gaussian. This message also takes no parameters and returns a random number from a normal distribution with mean 0 and standard deviation 1. The layman's term, this means that the result may be either positive or negative, with both being equally likely. The numbers will almost always have small absolute values. For example, translating and scaling random numbers. Random number generators often return numbers in some limited range, typically 0 to b for some upper bound b. Sometimes you need your random numbers to lie in a different range. You can make random numbers lie in a longer or shorter range by multiplying them by a scalar factor, or can make random numbers lie in a range that is shifted to higher or lower numbers than the original by adding or subtracting an offset from the random numbers. Here are some examples of these operations. Suppose you are writing a game program that simulates throwing dice and need a random integer in the range 1 to 6. NextInt can give you 1 in the range 0 to 5, and you can translate this to the range you need. Suppose the same pattern drawing program also needs to pick random lengths for the lines, but that the line should never be shorter than 10 units, no longer than 50. Line lengths can be any real number between these limits. Thus, you need random lengths from a 40 unit range starting at 10. You can use scaling and translation together to guarantee these numbers from next double. So, let us have a look on Python. The standard random module implements a random number generator. Usage is simple. Import random, print random.random. This prints a random floating point number in the range 0 to 1. There are also many other specialized generators in this module, such as randrange AB chooses an integer in the range a to b. Uniform AB chooses a floating point number in the range AB. Normal variant mean SDiv samples the normal or Gaussian distribution. Some higher level functions operate on sequences directly, such as choice S chooses a random element from a given sequence. Shuffle L shuffles a list in a place, that is, permutes it randomly. There's also a random class you can instantiate to create independent multiple random number generators. Generate pseudorandom numbers. This module implements pseudorandom number generators for various distributions. For integers, uniform selection from a range. For sequences, uniform selection of a random element, a function to generate a random permutation of a list in place, and a function for random sampling without replacement. On the real line, there are functions to compute uniform, normal or Gaussian, log normal, negative exponential, gamma and beta distributions. For generating distributions of angles, the von Mises distribution is available. Almost all module functions depend on the basic function random, which generates a random float uniformly in the semi-open range 0.0 to 1.0. Python uses the Mersenne twister as the cogenerator. It produces 53-bit precision floats and has a period of 2 to the power 19,937 minus 1. The underlying implementation in C is both fast and thread safe. The Mersenne Twister is one of the most extensively tested random number generators in existence. However, being completely deterministic, it is not suitable for all purposes and is completely unsuitable for cryptographic purposes. The functions supplied by this module are actually bound methods of a hidden instance of the random.random class. You can instantiate your own instances of random to get generators that don't share state. This is specially useful for multi-threaded programs, creating a different instance of random for each thread and using the jump ahead method to ensure that the generated sequences seen by each thread don't overlap. Class random can also be subclassed if you want to use a different basic generator of your own devising. In that case, override the random, seed, get state, and jump ahead method. As an example of subclassing, the random module provided by the Wichmann-Hill class, which implements an alternative generator in pure Python. The class provides a backward compatible way to reproduce results from earlier versions of Python, which use the Wichmann-Hill algorithm as the core generator. Bookkeeping functions. Seed. Initialize the basic random number generator. Optional argument x can be any hashable object. If x is omitted or none, current system time is used. Current system time is also used to initialize the generator when the module is first imported. If x is not none or an int or long, hash x is used instead. If x is an int or long, x is used directly. Get state. Return an object capturing the current internal state of the generator. This object can be passed to set state to restore the state. Set state. State should have been obtained. From a previous call to get state and set state, restore the internal state of the generator to what it was at the time set state was called. Jump ahead n. Change the internal state to one different from and likely far away from the current state. N is a non-negative integer which is used to scramble the current state vector. This is most useful in multi-threaded programs in conjunction with multiple instances of the random class. Set state or seed can be used to force all instances into the same internal state, and then jump ahead can be used to force the instances state far apart. Instead of jumping to a specific state n steps ahead, jump ahead n jumps to another state likely to be separated by many steps. Functions for integers. Rand range, start, stop, step. Return a randomly selected element from range, start, stop, step. This is equivalent to choice, range, start, stop, step, but doesn't actually build a range object. Range int ab. Return a random integer n such that a is less than or equal to n and less than or equal to b. Functions for sequences. Choice seq. Return a random element from the non-empty sequence seek. Shuffle x, random. Shuffle the sequence x in the place. The optional argument random is a zero-argument function returning a random float in 0.0 to 1.0. By default, this is the function random.